So we want to find the area of the region inside the polar curve r equals 5 cosine of theta, but outside of the polar curve r equals 4 minus 3 cosine of theta. So let's look at the graph of these. The first one, 5 cosine of theta. So it's going to look something like, let's see, 1, 2, 3, 4, 5. So it's going to look like something, a circle. That's good enough. So this is my, this is a graph for 5 cosine of theta. We change color, and 4 minus 3 cosine of theta is going to look something like this. Okay, this is close enough. So the question is asking us, we want to find the area that is inside of the first one. So that inside of the first one would be this shaded area, but outside of the second curve. So outside of the second curve, so this is going to be the one that has 2, that's shaded with 2 different colors. So now the first thing that we need to do is to find where is the intersection of these 2 graphs. So let me go ahead and go to the next page. And if I said 5 cosine of theta, so 5 cosine of theta equal 4 minus 3 cosine of theta, I can claim that 8 cosine of theta equals 4, cosine of theta equals 1/2, and theta is, so theta equals pi over 3 and negative pi over 3, or 5 pi over 3. So, and the formula that we are going to be using is area equals from alpha to beta 1/2 the outer radius, which is, so let's say R1 squared minus R2 squared and dr. That's the formula we want to be using. So now to make my life easier for alpha and beta, I'm going to just notice that there is symmetry in here. So instead of going, making that difficult for myself, I'm going to just go ahead and go from 0 to pi over 3 and twice that area. So area equals 2 times from 0 to and the formula is 1/2. The outer function would be 5 cosine of theta quantity squared minus 4 minus 3 cosine of theta squared d theta. Okay. Well, this 1/2, I can take it out and claim that area equals from 0 to pi over 3. 5 cosine of theta squared gives me 25 cosine squared of theta minus, let's see, 4 times 4 is 16. And I'm going to get minus 24 cosine theta plus 9 cosine squared of theta, all this d theta. Okay. And so let's combine this together. I'm going to get area equals from 0 to pi over 3. I have 25 cosine squared of theta, and I have minus 9 in here. So total of 16 cosine squared of theta. Then I have plus 24 cosine of theta minus 16, all that d theta. So I'm going to go ahead and go to the next page. I'm going to go ahead and just separate my integrals. So area equals 16 times from 0 to pi over 3 cosine squared of theta d theta plus 24, 0 to pi over 3 cosine theta d theta minus 16, 0 to pi over 3 d theta. You don't have to do this, but I'm just showing all the details. And the only one that I have to use an identity is this one. I'm going to use the reduction formula. So area equals 16 times 0 to pi over 3. Cosine squared of theta is the same as 1/2 1 plus cosine of 2 theta d theta plus 24 0 to pi over 3 cosine of theta d theta minus 16 0 to pi over 3 d theta. Okay. So the first one I can claim is the same as 1/2 times 16 is 8 from 0 to pi over 3. 1 plus cosine of 2 theta d theta plus the second and third part. Now I'm going to go ahead and take my integral. So area equals 8 times integral of 1 is just theta plus using chain rule in reverse, I get 1/2 sine of 2 theta. And that's from 0 to pi over 3 plus 24 sine of theta from 0 to pi over 3 minus 16 times theta from 0 to pi over 3. So area equals 8 times pi over 3 plus 1/2 sine of 2 pi over 3, so root 3 over 2. All that minus 0 plus 24 root 3 over 2 minus 0 minus 16 times pi over 3. And by the way, this was theta, not 0. This pi over 3 from 0. Sorry about that. 16 times pi over 3 minus 0. Okay. Going to the next page. So area equals 8 times pi over 3 is 8 pi over 3 plus, then I got root 3 over 4 times 8. So 8 root 3 over 4 plus 24 root 3 over 2 minus 16 pi over 3. I can reduce the 8 pi over 3 plus 8 over 4 is just 2 root 3 plus 12 root 3 minus 16 pi over 3. Okay, let me plug all that in my calculator. So I have 8 pi over 3 plus 2 root 3 plus 12 root 3 minus 16 pi over 3. According to my calculator, 15.8711309. Okay, thanks.